it's 7 volts, but let's just keep it. So this is the motor actually. Okay, and here is a transistor. There is some connection for the transistor. You can combine two transistors together and make something called the Darlington pair. Okay, so in the slide that I showed you, he is not using a transistor. He is using this called the Darlington pair. Okay, the Darlington pair is some connection between two transistors that amplifies more the current. That's not our topic now. But if you have to do that yourself, you should buy some, some IC that has this Darlington pair. Now, there was there was this guy here, okay, this diode. And we want to know why he is using this diode. Okay, when you switch on or switch on, let's take a switch off, for example. So when you switch off, this means there was a current, IB. So if we draw the current, IB versus time. When we switch off, that means there was a current with some value. Then at some point, it drops to 0. So the voltage of the coil, the EMF that I'm saying, is equal to L, which is the inductance of the coil, di by dt. Guys, when you have a very large, abrupt change like this, from high to low, this here di by dt, theoretically, it's equal to infinity. Very high. Practically, it will be very, very high. 100 volt, for example, something like this. So this 100 volt can crash the transistor. The transistor will just burn. Okay. So we need something to absorb such, such a change. And this actually is, the diode. So this diode here, they will draw right now. Will do that for us. So this guy, to absorb such huge current or voltage when switching on or off. Okay. Because this EMF has a polarity like this. So when you have a polarity like this, this diode will be forward biased. So the current will flow, instead of flowing in that direction here to the transistor, it will flow into the diode. Okay. That's why we need this this diode in here. So let's go back to that guy here. Okay, so this is why we need such diode and such transistor to interface our microcontroller to the motor. Okay, there is a problem though, because this source here, VM, okay, you provide the source to feed the motor. So you want all the voltage to go to the motor. Okay, so if we go here, so this VCC here, part of it will go to the motor between these two terminals, and another part will go to the transistor. To this is called the VCE, the voltage between the collector and the emitter. So VCC is equal to V motor plus VCE. For the Darlington pair, this is around 0.5 volts. So you will lose around 0.5 volt out of your VCC, which is big. Okay, that's why we have another type of connection, which is this one. Okay, so you add another transistor. Now it's not a BJT transistor, it's VDS, it's NMOS transistor. Okay, and now let's now see how this circuit will operate. So if you have high here, then this will work. Okay, and if this will work, all the current will go into the transistor, the BJT transistor, and nothing will go to the VGS, the voltage between the gate and the source of this NMOS transistor. So it will be off. And if this guy is off, then the current, there will be no current flowing in the motor. So the motor will not rotate. So it's opposite to the first circuit. The first circuit, when you have high here, there will be a current in the transistor, so the motor will run. And if you have low, the motor will not run. Now, if you have high, the motor will not run. But if you have low, the transistor will not work. So the current flowing into the transistor will be 0, and all the current will flow to the NMOS transistor that come from the VM, the battery you have. Okay, this guy will work. Usually the voltage here is around 0.1 or 0.2, not 0.5. So most of VM will go to the motor, and the motor will rotate, with higher strength, we can say. Okay. But we have a problem so far with either this circuit or this circuit. We have a problem, is that the motor will run in one direction. So the motor is a very nice circuit. So as a circuit element, if we look at the motor, let's go back here to this slide. So if you have a motor like this, good. If the current flows in some direction, for example, it will rotate like this. So this is one phase. And if it runs in the opposite direction, so this is called I1, for example. If it runs in the opposite direction, I2, it will rotate in the opposite way. Okay, so this circuit here has only one direction of the current. The current is flowing from VCC or this battery to the transistor. No other direction. The current can't flow in the other way. So we need a more smart circuit from which we can run the motor in two ways. Okay, so let's see how we can do that. We can do that using this bridge here. This is called the bridge. Just to forget about this one. Just look at the one on the right. Okay, so let's see how it works. So let's draw it in the. So let's take this first. This is a snapshot. Okay, and let's go here. If you put 1 in Q1 here, or high voltage, let's say high, and high in Q4, and low or 0 on Q3 and Q2. So this guy will be off, this guy will be off, and you will have a current flowing in that direction from the source here. The current will flow in that direction, like this. Then if you do the opposite, if you put 0 here and 0 or low, logic. So you put 1 there. If you put 1, then this will not make it, this will make it sleep. If you, I'm sorry, if you put 1, it will not sleep, or it's on. If you put 0, it will not, it will sleep. Okay, so the IC will be off, so the motor will not run. Okay, so this is a chip that you have on the board. I don't know why it's not working. That's fine. So this is a chip that you have 2 of them, one to control the left motor and one to control the right motor. So this is for example the one that controls the left motor. Okay.
Hey, Professor.
Yes.
Can you go back to, can you please explain pin 6 and 5 again, just briefly?
Yeah, phase BH is it's called the phase bin. Okay. So if you put 1, it will go backward. If you put 0, it will go forward. It's a negative logic. Okay.
Okay.
So this is the function of of bin 6. Bin 5 is called enable. Okay, just to forget about its name. It's actually used to control the speed. We will see that in 2 lectures or 3 lectures. Okay. But for now, if you put 1 there, the motor will run with its full speed. If you put 0, the motor will not run. So this is how you can understand how it's basically controls the speed. If you put 1, it will go to its full speed, so the motor will run, and the robot will move with its full speed, highest speed. If you put 0, it will go with its lowest speed, which is 0, so it will not run. Okay. In the future, we will make a kind of combination between 1 and 0, in somehow, so that you can go something in between, not the full speed and not 0.
Yeah. Okay.
But for now, it will be 1.
Okay. Thanks, Professor.
Just forget about this. Yeah. Here is the connections that we're gonna use today. So again, we have two chips. One to control the right motor and one to control the left motor. So this is the left motor, this is the right motor. Okay. And here is the pins that we're gonna use. Okay, this slides actually is used for the same kit, but I think older versions. So that's why there is some typos here. Not typos. Maybe for that kit it was right, but for our kit it's wrong. And this is only just 2 pins, which is these 2 pins in the beginning here. So let's understand this. Let's see, enlarge them. Okay. So first of all, let's forget about these are these are the direction pins. Okay. So here for the kids that was before, it was port 1. No, now it's port 5. So pin 5.4 in the microcontroller and the pin 5.5 both will control the direction of the motor, either forward or backward. Okay. Pin 5.4 will control the right motor direction. If it's 1, the right motor will move forward or rotate forward. I'm sorry. If it's 1, it will rotate backward, and if it's 0, it will rotate forward. I will show you why it's 1 or 0 forward or backward. Okay, but just take it like this, like that for that moment. And pin 5.5 in our microcontroller will control the direction of the left wheel or the left motor. Okay. If 5.5 is 0, the left motor will move forward. If it's 1, the motor will move backward. Okay. How is this? Just look at the connections. So this should be 5.4, and it's connected to the phase. As I said to you, phase pin in this driver chip is to control the direction, and the other one is also connected to the phase pin. Okay. Now the speed. The speed is controlled through this enable pin 5 in these chips. So to which pin these pins are connected? They are connected to in 2 pins in port 2. So pin 2.6 will control the speed of the right motor, and the pin 2.7 will control the speed of the left motor. And as I said, for now, we will just put 1 there on 2.6 or 2.5 so that the motor will run with its full speed. If we put 0, it will just stop, or the lowest speed, which is 0. And finally, the sleep pins, which are pin 7 in both chips here. These 2 pins are connected to 2 pins in port 3, port 3.6 and pin 3.7. Okay, so if we put 0 there, for example, in pin 3.6, this is connected to the right motor sleep. So if you put 0, it will sleep. It will not work. Okay. If you put 1, it will. If you put 1, then you look at the phase and the enable pins, what kind of voltages they have. Okay, so to know if it's going forward or backward, and also the speed. Okay, and this is resumed here in this, summarized here in these 2 tables. So for example, for the left motor, pin 1.7 is actually pin 5.5. So just, forget this for a moment. It's just 0.5.5. I don't know how to correct it, but anyways. So this should be pin 5.5. So if you have on pin 5, where is the sleep? Yeah. If you have on pin 5.50, and you have for the enable, which is pin 2.7, this one. If you have 0 on the enable, this means the lowest speed or the minimum speed, which is 0, so it will not run. So it's like a stop. Okay, whatever the direction is. But if you have on pin 2.7 1, now the motor can run forward or backward. This will be determined from pin 5.5, not 1.7. So if there is 0, it will move forward. If it's 1, it will move backward. Okay, and the same for the right motor. Okay, this is the most important for our lab. This is the most important slide. Okay, I will just now correct this.
Professor?
Yes.
For the enable, would it still be port 2 for both of them?
Let me correct this for a moment. We can write here 5.5. Good. Okay. Yeah, what's your question?
For the enable, would it be port 2, or would it change? Because how port 1 changed to port 5.
Okay, for the enable, let's look at here. So this is, for example, B2.6. Let's trace this line, this wire. It's connected to the enable. And 2.7 is also connected to the enable. Okay, this is. Did I understand your question right? Or
yeah, but you know how you're changing port 1 to port 5 for our robots? Is it still the same for our robots with this?
Ah,
instruction. Yeah.
no, you should change. So this is wrong. For our robot, it's port 5. Bin 1.6 will be bin 5.4.
But then the other ports, are those correct?
Yeah, these are correct.
Oh, okay.
Yeah,
All right.
yeah.
Thank you.
It's 5.4. Okay. So good. Yeah, so this is basically what we're gonna do today. We're gonna test. Yeah, this is just a summary. So let's keep this in front of you. All the time. Okay. So I will share the other screen right now to show you the codes that we're gonna run today. You guys can see my other screen?
Yeah.
Okay. So I just highlight what's in there for you because it's a lot of coding. So first we're gonna see why these bins in particular. So I think I have the kit here. How could I know which bin is connected to the chips? This is known from the user guide. So look, you can look at this big table here, or for each peripheral you have on the kit, there is a separate, separate a table like this. So these are the bins of the motor. So left motor direction is connected to bin 5.4, not 1.6 or 1.7 like here. Okay. And the right motor direction is bin 5.5. These are the two bins that have they change it from the versions that this slide is based on. Okay. Enable, which is this is actually the sleep. So this is let's call it sleep to make it clear for you. Some problem, I don't know. Okay, so this is the sleep bit. Okay, he call it enable, although the enable should be this one. BWM is the way that we're gonna change the speed. Okay, but he call it the BWM. I will show you in 2 lectures why it's called the BWM. Okay, but it's not so this is not our topic right now. So these are the bins. So as you see, bin 3.7 is the enable the sleep bin for the left motor. 2.7 is the enable bin. Okay, just forget about this naming here. And again, 2.7 is the one that we're gonna control the speed for the left motor from. And 5.4 is the direction. For the right motor, the direction is 5.5. The enable, or the one that we control the speed, is 2.6, and the sleep is 3.6. Okay, they are summarized here. So let's see what we're gonna do. So we need, so I just copied and paste what we need here. Okay, and let's write this in the sleep signal. And here is enable and parentheses. We can see. Okay, so these are the bins that we need. So we need to configure them as a GPIO. So to use these pins, we will send some signals through them. So they are output pins. So we must configure them as GPIO output pins. So these are for the right motor. This is the initialization step. For the right motor, we need 3 pins, 3.6, 2.6, and 5.5. Okay. So set GPIO as output pin port 3, pin 6, this one, which is asleep. Then we put, because we're gonna use the motor, so just put there something so that it will not be in a sleep mode. It will be active. So we put there high. It's a negative logic. If you put 0, it will sleep. If you put 1, it will not sleep. So negative logic. Okay. Now the 2.6 or 5.5 for the direction, 5.4, this is 5.4, and this is 5.5. So the right motor direction is through pin 5.4. So we're gonna set it as output pin. Okay. Then pin 2.6, it will be an output, and through which we're gonna send 1 so that it will run full speed, or 0 to stop it. Okay. And initially we're gonna put 0 there, so it will be stop in a stop mode, which is actually the initial condition. The same for the left motor initialization. Okay, first the sleep pin, it is pin 3.7, and we put 1 there, so it will not be sleep, it will be active. Then we initialize pin 5.5 for the enable, for the direction, and we initialize also pin 2.7 as output, and we put 0, so the motor will be stopped initially. Okay, so the first thing, we initialize the motor, so this function will be executed and the motor will be initialized. Okay, the motor drivers will be initialized. Then in this while loop, what I'm gonna do, I'm gonna go backward first, then stop. So first is the right wheel backward, then stop, then the right wheel forward, then another stop. Then I will do the same for the left motor, left wheel. First I will run it backward, then stop, then forward, then stop. Then I brake here, which is not usual, but just to avoid, because I just want to test if it's going forward or backward, our main configuration is working or not. So I don't want to consume a large power. And by the way, my battery is just drained out from one day of use yesterday. So that's why I put a brake here. Okay. So guys, start writing this code, okay, from the screen. Until because I need to replace the batteries in my robot. Once I replace them, I will test it in front of you. Okay, but just start writing it. So I will put it here in front of you, and you guys start writing or copying this code into your computer studio. Yes, Clark.
Would it be possible to go down real quick just for people to take a screenshot of the main?
Yeah.
Thank you.
You finished?
Yes, thank you.
Okay, go ahead until I try to fix that. Guys, remember if you're gonna buy Energizer, batteries, buy the one that is 1.5. This is 1.2. I don't know if you can see this. This is 1.2. Okay, it works, but some LEDs on the chassis board, not this one, the chassis board itself, will not work. But it will run the motors. Okay. So if you're gonna buy an Energizer, look out for this. Buy something that is 1.5, not 1.2, like this one.
Hey, Professor, I just have a question.
Yes.
On line 22 of your code, on the comments, should it be P5.4?
Line what?
Line 22 in the comments.
Oh yeah, because I okay, 5.4. Thank you very much.
Okay, thank you. I
And
just
here
wanted
is
to double check.
5.5. Yeah, this takes me 1 day, by the way, because I trusted this source, this slides, and I was using 1.6 and 1.7, and then they turns out they are the wrong connections. This takes me 1 day. So I'm gonna show you very quick. Okay. Where is right? This is right. Yes. So there is, a kind of paper here. Let me do it in that way. Yeah. Let me do it in that way. So I just stack a piece of paper to the wheels, to both wheels. Okay. You see small papers, this paper and this paper, okay? Just to,
Professor, I think your video screen is frozen.
Yeah, your video screen is frozen, Professor.
I don't know.
I
Still
just see a
frozen.
black screen.
The what?
I just see a black screen. That's it.
Okay, let me stop sharing my screen. Yeah, there is a problem with Skype, with Zoom right now. So I'm gonna show you the, you know, the motor while it's running. Okay. So just okay. First is this is the right wheel. I don't know if you can see it. I'm gonna try. Okay. So look at this, you know, paper here, how it's rotate to know if it's really moving forward or backward. Okay, let me write now. And this guy. I have another idea. Okay. I have this. Okay. Then it will go in the opposite way. Same for this one. Look at the yellow paper. Then the opposite direction again. Okay. So you should have something like this.
Mr. Mustafa,
Yes.
when the wheel moves towards the bumper switches, that's going forward, right?
Towards the bumper, yeah. This is forward.
Okay.
I start backward, then forward for some historical reasons. But you can do the opposite, that's fine. Just copy and paste, you know, switch them.
Right. Okay.
Yeah, and also put something behind. So I put this stuff here, you know, anything you have, put it underneath here, so that there will be space between the wheel and the floor. Okay, so you can have it, you know, running or looping without touching the floor. Okay.